So today I'm going to talk about the Magnetic Crusade, which is sort of the secret agenda behind John Franklin's doomed search for the Northwest Passage. So, all right, so in 1845, two Royal Navy British vessels left England to ostensibly look for and complete sort of the final leg of the Northwest Passage, right? This mystical link that links the Atlantic Ocean to the Pacific Ocean through the Arctic Circle. And these are really the most best equipped, most technologically advanced ships of the time, the Erebus and the Terror. And they were last seen after leaving England in 1845. They resupplied off the coast of Greenland, and they were last seen entering an area called Baffin Bay by European whalers. And then they vanished, and no one saw anyone from the expedition alive again. So it's kind of a bit of a mystery and a ghost story kind of all rolled into one. So the Northwest Passage, if you're not familiar, is this idea that Europeans were trading with Asia, with China in particular, the trade with India through various royal companies. And the thought was, well, if we can go over North America, we can get there a lot quicker, save months of shipping time, save thousands of pounds. And the idea is that, well, if we can just kind of head up this way through Baffin Bay, this kind of area, this bay between Greenland and Baffin Island, then surely we can chart our way through and find a channel, and then kind of on the other side go through the Bering Strait between Alaska and Russia. And Alaska at this time period was also part of Russia. So this was the idea, right? In reality, it was much more difficult than it seemed, because although you can look at this map, and I'll show you kind of more of a detailed picture, right away you can immediately identify here's a channel that just goes straight through and say, well, this should be pretty easy to get through. But what you have to contend with in the Arctic is ice. And there's a lot of ice. And a particular channel that might lead you to a Northwest Passage one particular summer may not be there the next summer. And so the idea that this channel was commercially viable was sort of a fantasy. And it was a long-held fantasy. I think people eventually started realizing that this Northwest Passage was never going to be commercially viable. Now, we live in the days of climate change, and who knows if this Northwest Passage in the future might become commercially viable. But I can tell you right now, I think I looked at the current temperature off King William Island, which is going to feature in our story, which is down here, and I think the current air temperature was something like -1 degree Fahrenheit, and there was a good chunk of ice off the coast. So even now that the Northwest Passage is open, you can, by the way, pay $25,000 and take a cruise through the so-called Northwest Passage. But there's no guarantee in today's day and age that you won't fall the same fate that John Franklin did, because it's very far away from civilized ports. So the Northwest Passage is a long and very interesting history. I mean, it was really sort of under the sort of British domain. They kind of considered this their particular holy grail. And really, since Elizabethan times, they went searching for the Northwest Passage. So Martin Frobisher, who was a famous explorer, famously said, "It was still the only thing left undone whereby noble mind must be made famous and remarkable." And a lot of these explorations were really about fame. Right? So Arctic explorers came back and were ignited. And then they sold their memoirs and became famous. So there was a lot of fame and wealth and riches to be made. And Frobisher's famous for his bay, Frobisher Bay over here. Baffin Island was named for him. Lots of other exploration. John Davis rediscovers Greenland. So this is sort of maybe European conceit, but Viking settlements that existed on Greenland for a long time that were abandoned and sort of Greenland kind of gets forgotten, which we discovered. Henry Hudson discovers Hudson Bay. So, this giant body of water here, Hudson Bay. Initially, they thought, well, this surely will lead to the Northwest Passage, and then sort of dead ends. So it doesn't work out very well. That story ends in tragedy, like many of these stories do. Hudson was convinced that this was a passage through and wanted to continue going west, and his crew was tired and hungry, and scurvy was developing, and they didn't want to, so they stuck him on a boat with his son and a couple of sick crew members, and basically cast them adrift. And he was never heard from again. So then the crew returned to England, and I guess they did some quick enough talking that they didn't get too much trouble for this, but his second command, Vylot, ends up sailing with Baffin a few years later, and they discover three sort of broad avenues out of Baffin Bay that are interesting. Lancaster Sound we'll hear a lot about, and Smith Sound and Jones Sound. And Jones Sound is sort of the road to the North Pole. Luke Fox looks for channels inside of Hudson Bay, tries to find a way through the passage through Hudson Bay, like Hudson before him, doesn't find anything. Christopher Middleton, sort of a century later, tries again, hits this dead end in what they call Repulse Bay. They were repulsed from the search for the passage, is why that's named that way. And sort of for a while, Regency Britain sort of forgets about the Arctic. So there's a lot in history that's going on. Sort of end of the 18th century, you have, you know, the revolution in France, and then you have the whole Napoleonic Wars, and everyone's sort of, you know, everyone's, you know, sort of justifiably preoccupied with that notion, right? So there's no manpower to go sailing off on these sort of wild, fantastic voyages. And people even sort of certain maps start removing Baffin Bay. And then when they rediscover it, they discover that, oh, Baffin's maps were actually very accurate. So, but it also could be that ice levels during this time period were a lot higher than in times past. So Baffin Bay was sort of not really navigable. But the interesting part of the story is that there's sort of this whole story will be a story of sort of European pride and arrogance. That, you know, this British aristocracy can go and sort of bend this wild wilderness to their will. And whalers had been using these waters, you know, for a long, long time. And whalers knew that Baffin Bay existed. And whalers knew that, you know, that what the Arctic was like. And they really didn't ask the whalers much. They eventually, you know, whalers would come along some of these passes, some of these expeditions as what they called ice masters. But they're never put in charge of expeditions, which was kind of a shame. So. All right, so Napoleonic War is over about 1815, and Britain is really just the undisputed master of the oceans, right? They control the oceans of the world. Right? The sun never sets on the British Empire. And what happens is there was about 140,000 sailors at the height of the Napoleonic Wars, and they get, right, there's these gangs that would go around pressing soldiers, pressing sailors. They get sort of laid off, right? So we don't need these many sailors anymore, but officers are retained. And so you have about 19,000 sailors left in the Royal British Navy and 6,000 officers. So about a 3-to-1 ratio of sailors to officers. Now, the officers are on half pay, which even for post captains means that you're living on sort of paltry and meager wages. So there's this kind of general hunger amongst the officer class of doing something and getting, you know, like there's no route to advancement anymore. The Napoleonic Wars, right? Your superior died, you quickly, you know, got battlefield promotions. This isn't happening anymore. So people looked at exploration as sort of this natural outlet for kind of this this expertise that the British Royal Navy had kind of come up with and maintained. So Russia, sort of at this time, is the only real geopolitical foe that Britain has, and there'll be all sorts of conflicts with Russia all over the world, particularly in the Middle East. So not too much in the middle of this time period, in the middle of the 19th century, right? Britain gets involved in Afghanistan, and so we see echoes of that in our, you know, United States history. But Russia at this time owns Alaska, and so there was a significant worry about Russia kind of pressing eastward and encroaching on the Hudson Bay Company holdings. So this very rich area where furs and other kind of natural resources were coming from. So there's a lot of worry about that. But John Barrow is this really interesting figure. He, unlike many of his contemporaries who become important, he's not a nobleman. He's actually the son of a farmer. And he eventually ends up as second Lord of the Admiralty, Secretary of the Navy. And it's a very important position. He's basically in charge of outfitting and sort of deciding on what we're going to do with the Navy and, you know, control of the purse to some extent. And he's really known as the father of British Arctic exploration. So he really pushes this idea of, you know, the 18th century was famous for all these voyages of discovery. So, you know, Cook's voyages to the Pacific and Hawaii and these types of things. Well, let's start off and have a new century of exploration, a new century of voyages. But, right, under, you know, of course, Britain is going to be predominant here, right? We want to make these discoveries for the British Crown, and we want to make sure that we get to do it first. There was this kind of paranoia amongst the English that someone else would get to it first, and I'll show you a quote from him. But one other kind of aside is that he was a big proponent of what's called the open polar ocean. And so it was thought at this time period that there was this belt of ice that sort of, you know, spread around the North Pole. But if you got through the belt of ice, you'd be in open waters. And then potentially a route to the Northwest Passage would mean going north, fighting your way through the ice, but then sailing across open waters and then going back through a field of ice. And so even as late as 1845, when we see the Franklin expedition going, people were talking about this open polar ocean theory, which just turned out to be disastrously wrong. So, great quote by John Barrow. So it'd be somewhat mortifying if a naval power put it yesterday, like the Americans or the Russians, right? She completed discovery in the 19th century, which was so happily commenced by Englishmen in the 16th. So the worst thing could happen is those darn upstart Americans discovered the Northwest Passage, right? Or the Russians did it. And so this was a way of claiming the Arctic, right? If the British had the maps and they sent the men to do this, right, they would own the Arctic and they could claim that area. And if this commercial passage ever was discovered, right, then Britain would gain. So Barrow immediately kind of in this time period starts sending out Arctic expeditions. And I'm going to talk a little bit about some of the exploration first, and then we'll come back to physics and kind of talk to you sort of how in this very nonlinear fashion I came across and started noticing that there was a lot of interesting science going on. But let me tell you a little bit about some of the first expeditions that happened. So the one thing I tried to include is a lot of maps because there's a lot of geography that I wasn't familiar with, and I don't know, where's the island of Svalbard? Well, here it is off the north coast of Norway, also called Spitzenberg. It was under Norway's control. But basically they sent some ships and they decided to go basically straight north, trying to reach that open polar ocean. And these are sailing vessels that they sent, and there was no design, perfectly designed Arctic exploration vessel. They sent either cargo ships or British warships, nothing that was purpose-built for this kind of exploration. And these are sailing vessels. So even if you're trying to work your way through the ice, imagine there's leads where there's open patches of water. The wind's not necessarily blowing in the right direction, or even using tacking, you may not be able to get through there. So what they did was they would throw their anchors on the ice and winch themselves through passages. And it was basically back-breaking work. If they got stuck in the ice, they would send men out with saws to try to saw through the ice, open up channels, to use gunpowder and explosives and things like that. I mean, horrible, horrible work in freezing, sub-zero Arctic conditions. They didn't get very far. John Franklin actually was second in command of this mission. He was a lieutenant at the time. He'll feature prominently in some of the later discussions. But this was basically a disaster. Nothing good came of this. They never discovered an open polar ocean. They got actually not too far up. After that, John Ross, sort of around the same time, sets off through Baffin Bay. And so we're going to say, all right, we'll try a different pronged approach. So one of them will be going north from Svalbard, one will be going through Baffin Bay. And so John Ross sails up through Baffin Bay along the coast of Greenland and does a little bit of exploration, explores Smith Sound a little bit, and then comes to a point, and in the writings it says that he looks off in the distance of Lancaster Sound. So this entrance into the Arctic labyrinth, this is Lancaster Sound right here. And it's said that he sees a mountain range that blocks all further progress. And the thing was that no one else saw the same mountain range, and no one else saw this. I mean, it was foggy, the conditions were really bad, and he's convinced that this is the dead end, so he basically takes his expedition, turns around, and goes home. And William Perry, who's another Arctic explorer, was the second command of this mission, didn't agree with him, doesn't know why this happened. And when he gets home, he's basically mercilessly attacked by John Barrow. John Barrow was not a nice man. Much the time when you already study your history, you find out that Newton was not such a nice man. But Barrow was, after what he was after, and he was not sort of, squeamish about destroying anyone who got in his way. And so basically in the press and in the pamphlets, John Ross gets destroyed, and he's never really given command of another Admiralty mission to the Arctic again. We'll see he goes back again, but it's sort of under private auspices. So William Perry, who was the second commander of this voyage, then gets tasked to continue other voyages. And in 1818 and 1819, he actually gets farther west than anyone has ever gotten in the Arctic before. And he enters, here's Lancaster, Baffin Bay. Here's Baffin Bay up over here. Baffin Bay right up over here. Lancaster Sound. He goes through Barrow Strait, you recognize the name. And he gets to what he calls Melville Island. So Melville was the first lord of the Admiralty. He names is after him. So all the Arctic explorers have their names dotted across the Arctic. And he winters over in what he calls Winter Harbor. He is sailing on the Hecla and Griper. So they do an overland expedition up into across Melville Island. They find this bay they call Hecla and Griper Bay. And there's actually a prize from the Royal Society for the farthest distance west that someone has gotten. It was 5,000 pounds. William Perry's portion of that was 1,000 pounds, which was sort of enough to make you rich at the time period. It's a lot of money today. But eventually they want to continue, but there's just pack ice. Really thick, old ice coming down from the North Pole that prevents them from going across. And if you looked at the maps when we first started, this kind of northerly route seemed like the most direct and most obvious northern passage route. And it turns out that the pack ice coming in kind of in this region over here off the map is just impassable. that the only way you get through this, even today, is with an Arctic icebreaker. So a really big, nuclear-powered vessel or something along those lines. So that doesn't work. He goes back. He gets sent out again. The second voyage is, okay, let's try a different approach. Let's go through Hudson Bay. And so he sails up through Hudson Bay, explores Repulse Bay again to make sure that it was really a dead end. It turns out it really was. And then they go up the northern coast. They go to the Fox Basin. And they come and they find this intriguing strait that they name after their vessels, Fury and Hecla Strait, that's frozen over. But this seems like a really promising passage out of Hudson Bay into the Arctic labyrinth to get to the Northwest Passage. And they sit there through a whole summer waiting for this strait to unfreeze. And it never happens, and they basically have to turn around and go home. So they got so far, but they kind of map some coast, but nothing happens. And sailing on this vessel is a young midshipman named Francis Crozier, who we'll hear more about as well. So this is his first Arctic voyage. His third voyage, basically nothing good happens. He goes back through Lancaster Sound, and then he sails south along the coast of, this is Prince Regent Inlet, along the coast of Somerset Island is that right here. And basically, disaster happens from the very beginning. He gets into Lancaster Sound. He's in a sailing vessel. A gale blows him out. He's back in Baffin Bay. He tries again. He kind of winters over in Baffin Island for 10 months. So imagine a lot of these Arctic explorers are wintered in the ice for 10 months at a time, right? In the Arctic, pitch black, right? There's no sun during some portions of the year, or maybe you get a couple of even towards the end of winter, you're only receiving a couple hours of sunlight. So finally, they're able to get out of their winter harbor. The ice melts. They come along down this shore, and storms slam Fury up against the beach. They try valiantly to get Fury off. An iceberg comes along and pins Fury to the beach, and they basically give up, so there's no way we're going to get this. They transfer everyone to Hecla. They unload a bunch of stores on Fury Beach, which will be important for other Arctic explorers later on, and they come back. So sort of give up, or we've given up. And then Perry's final voyage is they try to shoot for the North Pole again. And this time they said, okay, we're getting smart. We're not going to try by sea. We're going to try by land or by ice. So they basically sailed as far north as they could until they reached the ice path. And then they disembarked. And, if you think of Arctic explorers, I think a lot of times we think of the Inuit, or we think of the Eskimo tribes, and we think of them on dog sleds and light sleds. Well, Europeans weren't unfortunately that bright at the time. And what they did was they carried heavy boats on very heavy wooden sledges. Because the thought was, remember, just up here, somewhere, there's the open polar ocean, so we're going to have to sail to the North Pole. Well, they never quite reached the open polar ocean. And actually, what they're on is sort of an ice conveyor. So as they're there, ice is continually moving. So they say at one point, one day, they made something like 11 miles, and they found themselves 3 miles south of their starting position that day. So they quickly realized they're getting nowhere. They also were doing this during summer, which is a terrible time because the temperatures are getting warm enough that ice is melting. So there's lakes in the ice, so they have to, take the boats off the sledges, get them in the ice, go a little bit further, put them back on the sledges, carry them. Right, ice is melting. There's just horrible, horrible conditions. And it turns out that the only way that Perry and then James Clark Ross, who's John Ross's nephew, survived is because Francis Crozier, who's on this mission, is now a lieutenant. He's cached supplies for them all along the route. So it's only because of Crozier that they basically able to come back and look, we can't conflict with it. And no one makes it to the North Pole for a very long time after it. It's just tough. Okay, so the word on ice. We think of ice, and I think the temptation for a lot of us is to think about, frozen lakes of, childhood that you could go skating on, right? Nice, even, pristine surfaces. And ice in the Arctic looks a lot more like this. So ice, right, moves from the pack down to the North Pole through these channels. It butts up against land, creates what the Russians call seracs, right? Russians have a lot of different words for ice, it turns out. So sort of understand why. But there can be these towering ice walls, and imagine trying to drag, a 1,000-ton, or a 1,000-pound or a couple-ton, boat plus sled over these seracs. And so you imagine the landscape, looks something like this, right? That sometimes these sheets of ice are pressing miles inland over islands and are, smashing and uprising and then melting. And so the Arctic environment is actually very, very difficult. And the Europeans were just not at all prepared to do this at all. Now there was some interaction with the Inuit, so some of them learned some things, but most of them didn't seem to learn enough. And I'll talk more about cultural differences in a second. So, at the same time, we also had some overland expeditions. So they thought, okay, well, let's not go by sea, let's go by land, and let's try to map the coastland of northern Canada. So John Franklin actually gets tasked with leading 2 expeditions. He comes back after the first and gets the nickname of the man who ate his boots, because he was not expecting to have to carry his own food. He thought that the Indians and the French voyagers that were sent with him would hunt and provide him with food. And it turns out that they very nearly starved to death. And it was only, so there's just all sorts of hardships. He ate, the leather off his boots. He ate a sort of tripe soup where he scraped lichen off of rocks and ate that. Horrible things happened on this first expedition. But he came back with almost everyone alive. And in the second expedition, he mapped actually hundreds of miles of Canadian coastline. And if you look at what's kind of left over, is that the unknown part is kind of in here, and the rest of the coastline almost through Alaska, a lot of this is mapped. And so what was sort of known, there was a lot of the Arctic coastline that was known, and there was just a small area that was unknown, which sort of contributed to this kind of hubris that, oh, we're almost there, we know exactly where we need to go. It's just a matter of a couple hundred more miles, and we'll have everything kind of figured out. So they learned a lot, but unfortunately they didn't learn everything. Okay, so getting over to the scientific matters. So Francis Crozier, who I think is a figure forgotten in history and sort of much maligned by history and by his contemporaries, he was really well reputed by his fellow sailors. He was an amazing sailor, an amazing captain. He reached the rank of post captain, but he was also an Irishman. So this was a period of a lot of prejudice. So he was not. So for example, he came back from his Arctic expeditions, and he saw other people get knighted for their tasks, and he didn't receive the same kind of rewards. But he actually developed, like I said, a very good reputation, and he was actually elected a member of the Royal Astronomical Society and the Royal Society, 1827-1843, for doing really remarkable work in astronomy and then in physics through the guise of terrestrial magnetism. So this to me was the kind of the first inkling of like, okay, what's going on here? That these British Navy officers are doing scientific work to the extent that they're actually being recognized by the sort of preeminent societies for physics and astronomy at the time period. And I got really interested in sort of what were they actually doing, and what do we mean by terrestrial magnetism, right? That's not a term we use anymore. So what is this terrestrial magnetism, and what were these sailors actually doing, and why were they so highly valued by the sort of scientific establishment at the time? So what is terrestrial magnetism? All right, so we've got to take a little detour back in history. So I'm trying to make this make as much sense as I could. So a lot of this is just kind of my thoughts that I'm trying to put together. But obviously, magnetism as a phenomenon was discovered by the Chinese, right, thousands of years ago. Europeans came to the game a little bit later, but really the first kind of treatise on magnetism was William Gilbert. And he wrote his treatise De Magnete. He was a court physician of Queen Elizabeth. And we think a lot about this early period of history, and we talk a lot about Francis Bacon, and sort of rationality and the science should depend on experiments. But Gilbert was saying these things even earlier, actually. So he was famous for that scientific theory needs to be firmly grounded in experiment. Right? It's a very modern way of thinking about science. And then he also says the Earth itself is a great magnet. Right? So he's recognizing this idea of the Earth's magnetic field and what it has to do with magnetism. And he's studying magnetism. And he actually models the Earth magnetic field as this tilted dipole. So what we know is that the Earth's north magnetic pole and the geographic north magnetic pole aren't the same thing. Right? They're tilted with respect to each other. So magnetic declination is basically just that fact that the direction between the magnetic north and true north just varies by some angle. So if you're on a location on your surface and you measure this angle, that would be your magnetic declination. So magnetic declination began to become measured all over the world, and people tried to come up with this map is sort of using more modern ideas to map it. But the idea was that every location on Earth would have a magnetic declination assigned to it. And then the thought was, well, could we actually use this as an aid for navigation, right? Besides the fact just a compass points north, right? Could we use it to determine where we are on the surface of the Earth? Is there a unique enough identification of magnetic declination with, for example, say latitude or longitude? And really people got very interested in this puzzle to solve what was called the longitude problem. And that gets us into the longitude problem is basically all about navigation. And the idea is that it's very easy to figure out where your latitude is, right? Basically, you look up at the sky, you see the North Star, measure the angle from the horizon to the North Star, that gives you your latitude. That's not hard. To figure out your longitude is very difficult. There was a long-standing competition between watchmakers, astronomers, and others trying to figure out the best way to determine longitude. The way the astronomers figured it out was actually using the moons of Jupiter. And that's a very complicated procedure. So actually an officer on a ship would go through actually hours of computation to try to calculate their longitude from astronomy. So people thought, is there an easier way to do this? Well, one easier way to do this is time. So you could say, well, so for example, let's say I know that in London, let's say at the observatory, this star rises at 12 midnight. And now I look at my clocks and I see the same star rise, but now it's only 9 o'clock. You can say, well, okay, my clocks differ from London's clocks by 3 hours. That gives me some notion of how far west I am. That can help determine my longitude. Well, now imagine you're on a pitching deck, and in the 16th, 17th, 18th century, what do clocks look like? They're pendulums, right? Pendulum doesn't work really well on the deck of a ship, right? So people try to figure out other ways of doing this. And actually, the problem got so bad that the Admiralty established and Parliament established what's called the longitude prize, which was the equivalent of about 2.7 million pounds today. So this was a sizable amount of money. And the problem really comes to head when actually the Royal Navy lost a squadron of 4 ships because they determined their longitude incorrectly and they ran aground in what's called the islands of Scilly. So longitude is just really tough. It's really hard for people to measure. So actually the longitude problem eventually solved by John Harrison. So if you've never read this book, it's called Longitude by Duda. It's a short little book, but it's really, really interesting. It's all about how John Harrison is a clockmaker, and he comes up with these amazingly sort of precision instruments, these little clocks that could basically tell time accurately so that you could determine your longitude. So when Darwin goes on the Beagle to the Galapagos Islands, they have something like 8 of these clocks or 17 of these clocks, to tell what time it is, and so they can accurately determine longitude measurements. So time becomes kind of the way people determine longitude. So the magnetic stuff is forgotten a little bit, but the theory, the thrust is still there. People still want to figure out, can we use this to determine longitude? Can we use this to help us make maps, determine position? But then they also discovered that there's another problem, is that if you measure your magnetic declination, so here's 3 historic measurements, right? One in 1580, one in 1622, one in 1634. They're all different. They're changing, right? There is a secular variation over the course of years. So magnetic declination changes with time. So, why, right? Why is this changing? Can we model it, right? That's the first question. Hey, can we figure out why this is happening, and let's make a model of it? There's actually a current model that has coefficients that change linearly over the course of 5 years. So people have done this, but this was kind of the quest at the time. Okay, how do we figure this out? How do we understand this secular variation? So Edmund Halley, who we all know sort of because of Halley's Comet, actually tried to get Newton interested in the theory of magnetism, and Newton wasn't really interested. Newton went on to do gravitation, which is probably a good thing too, right? But Halley decides, okay, fine, I'll take this on. And he's actually given command of a British vessel called the Paramour. And he makes 3 voyages at the end of the 17th century. And he takes lots of declination measurements in the southern hemisphere, and then takes other measurements made around the world and tries to map them together, stitch them together to make a map of the world. And his map is this. There's a picture of it. It's actually the first use of the contour line in sort of scientific plotting. So what he makes is he draws lines of constant declination. So those lines, the pattern is very strange, but they try to map the Earth as best as they can in terms of the magnetic field during declination. Now, Halley has this idea, well, the magnetic north is not the same thing as the geographic north. How do we understand this? Why is secular variation going on? Halley came up with a model that's sort of reminiscent of Aristotle's nested spheres for the solar system, where these interior spheres carry poles and they rotate. And so he came up with this quadrupole model where there was 4 magnetic poles. And he said, well, okay, look, how do we really answer how many poles there are, fit this theory's rest? So he said, well, we got to figure out how many poles there are first, right? That's one important thing. We want to figure out how does magnetic attraction decrease with distance from poles? Is it one of our squared laws? Is it one of our cube law? I don't know, right? And then, well, we have sparse and meager observations. We need to take more data. So if you're trying to figure out how many magnetic poles there are, where would it make sense to take observations? Well, near magnetic poles, which happen to be where? Oh, in the Arctic, right? So you're led back to, hey, maybe there's some interesting science that we want to do up in there. It's all about commercial interests. So. And then, of course, someone discovers at the same period of time, 1722, that there's not only a secular variation, but there's also a daily variation. And this daily variation has to do with the sun heating up the atmosphere, creating ions, which then conduct electricity. So you have currents in the atmosphere. So the phenomenon of the Earth's magnetic field is much more complicated than I ever thought when I first started looking at it. So. Okay. People added inclination. So imagine the magnetic field's a vector, and you got another 3 components, right? So we talked about declination. Let's add inclination. So I asked Tom Zepp if we might have a magnetic dip needle in the department, and he said, oh yeah, of course, it's in the conference room. It's sitting in the case on the bookshelf. So next time you're in the physics conference room, take a look on one of the bookcases, on one of the display cases. There's a dip needle in a little glass jar. And basically what it is a magnetic needle, and if it points down below the horizon, it's a positive dip. If it points up, it's a negative dip. Positive for down was because dips in the northern hemisphere were positive. And that's another measurement of the magnetic field. And then, of course, well, we'd like to have a third measurement to tease out the third component, or just what's the overall intensity of the field, right? The magnitude of the magnetic field might be a good thing to measure. And people tried to do this, and it was very hard to do. And then kind of Coulomb comes up with one possible explanation for how one can do it. And this was the method that people used for a very long time. And basically is that you say the Earth is your magnet, you take another magnet, and you set it oscillating, and you measure the period of its oscillation. So you can do the dip needle to just oscillate in the vertical plane, or you can do it in the horizontal plane, and measure the period. People made, I think today, as scientists, as experimentalists, I have nothing but respect for the people of the past because of the painstaking measurements they made. You think of like the famous oil drop experiment and how, they sat there and watched these little drops of oil and took all this. People would sit there in front of this dip needle and measure hundreds of oscillations every day. I guess maybe there were the modern distractions that we have. But they took amazing data with these things. And so with that, you can measure all 3 components of the magnetic field. But there's a problem. And if you work out the math, you can actually show that the period has to do with, you get the product of the magnetic moment of the magnet that you're using, the magnetic needle, and the Earth's magnetic field, the horizontal component. And you can't decouple them. So the problem with that is that if you use the same magnetic needle and you go around the Earth and you measure it, that's okay. But is that magnetic moment changing with time? Is that magnet becoming demagnetized? You have no way of telling. And so how is that affecting your results? So it wasn't until a little later people figured out how to actually kind of get around those results. Okay. So measuring the magnetic field. How did this really come to a head? When did people become really, really kind of driven to measure the Earth's magnetic field? It starts off with a Prussian by the name of von Humboldt. So he ended up publishing this series of books called Cosmos. So Cosmos with a K from the German, but they're really about sort of the natural world and about science and botany and sort of the best description of science that was around at the time. There's a character by the name of Edward Sabine who actually translates some of his books from the German into English, and we'll hear more about him as well. But he's initially really inspired by Cook's voyages to the Pacific, so the discovery of the Hawaiian Islands, the Australia, things like that. And so he decides to travel and basically as a naturalist and make observations, take measurements, look at new flora and fauna. This thing a little bit this time, and he travels extensively through South America, so through modern-day Mexico, Cuba, into Peru, Ecuador, things like that. And he makes several important measurements and discoveries. Well, one of the things he's very famous for climbing Mount Chimborazo in Ecuador, and he takes magnetic readings of the equator. And actually, Mount Chimborazo is actually the point on the Earth which is the largest distance from the Earth's center. It's not taller than Everest, but the equatorial bulge of the Earth contributes enough distance that it's the largest distance from the center. But he discovers that the magnetic intensity is minimal at the equator and increases with increasing or decreasing latitude. And he makes this measurement at the equator that is sort of the gold standard. Every other measurement after that is sort of relative to his measurement. So he kind of sets the ball rolling. He starts creating this network of observatories. So he goes back to Germany and starts convincing people to take these magnetic measurements. And then the British start taking these magnetic measurements and comparing them. And then they have these magnetic congresses. And so this was really an amazing kind of international effort at the time. And he actually works with a British figure, Sir Joseph Banks, who was president of the Royal Society for a time period. He sailed on Cook's voyages. He was also a naturalist. He gives Humboldt British instruments to do these magnetic observations. So there was a really international component. Okay. So Humboldt goes back to Germany, and he works with Jean-Baptiste Biot, right, who we all know from the Biot-Savart law for how currents create magnetic fields. So all these people are connected. He actually goes up in a balloon to try to determine how does the intensity of the magnetic field change with altitude. But their dip needle freezes over, and they're not even making conclusions. But they tried, right? And he basically gets everyone in Europe excited to work on this issue of terrestrial magnetism. So he really kind of kicks things off. And probably the most important thing he did, though, was to encourage Carl Friedrich Gauss to work on this issue of magnetism. And he's successful, much like Haley is not successful convincing Newton. Von Humboldt actually convinces Gauss to take up the study of magnetism. So Gauss is known as the prince of mathematics. He probably should also be known as the prince of magnetism as well. So he does a lot. So I would say this kind of marks the beginning of what I call the Magnetic Crusade. And Edward Sabine, who's the British scientist involved in this, says this is the great remaining physical mystery since Newton's work on gravitation. Right? Spooky action and distance force. We're going to try to understand this. Okay. So there's this big controversy. How do you model the field? Is it a dipole? Is it a quadrupole? How do the poles move? Where are they located? Well, you know, it'd be really cool if we could go to the Arctic and actually make these measurements and try to figure out where these poles are and what they look like and what the magnetic strength is and all that stuff. So, well, okay, up to this time period, it's really hard to go to the Arctic. You know, we said Baffin's Bay is all choked with ice. Europeans kind of forget about the Arctic for a while during Elizabethan times. And then all of a sudden, a whaler by the name of William Scoresby in 1817 comes back and he says, hey, wait a second, Baffin Bay and actually Greenland's east coast as well, there's this remarkable diminution in the ice cap. So for the first time in the last century, right, the way is clear. And so this is why a lot of these Arctic expeditions start happening. Remember, at the beginning I was talking about expeditions that left in 1818 and 1820s and 1830s. And this is what kicks it off. And so he publishes this book. It's called An Account of the Arctic Regions of the Northern Whale Fishery. And he's been to the Arctic his whole life. I mean, he grew up there, he sailed there, and he goes to John Barrow, who's the father of Arctic exploration. And John Barrow basically shuts the door in his face and wants nothing to do with him because he's just a stupid whale captain. What does he possibly know about the Arctic or about science? So a lot of William Scoresby's sort of insight into the Arctic region, how to sail there, how to survive there, what are the local people been doing, those kinds of things are really ignored, which is a shame. So, Colonel Edward Sabine. So, Magnetic Crusade becomes his sort of personal quest, his kind of driving passion behind his life. He actually goes to the Arctic in 1818 with John Ross, who sails with Perry on Hecla and Perry's first expedition, and becomes sort of obsessed with terrestrial magnetism. And he becomes a driving force in British science. So this whole story is really interesting, sort of how science drives public policy. You might imagine that sending these ships to the Arctic is a pretty big expense. I'll tell you about a mission to the Antarctic. It cost something like 100,000 pounds at the time. So it's in 1830. So 100,000 pounds then is a lot of money now. It's almost like, we said, you study your history and you say how much money was spent on Tycho Brahe's, island observatory in Brandenburg. It's like, it was like a fifth of the GDP of Denmark at the time, right? It was more of a sum. It was like the moon missions, right? So I mean, these are huge, huge expenses, and science is really driving public policy and actually naval policy as well. It's really interesting, and he basically makes sure that every future Arctic mission is really driven by magnetic science. It's not so much about exploration, but about magnetic science. So at this point, John Ross, who was discredited after seeing these Croker Mountains that actually turned out not to be there, he decides to go back to the Arctic. He takes along his nephew, so James Clark Ross, and he is convinced that the way to do these kind of Arctic missions is not with a giant ship full of lots of people, but with something smaller on a much smaller scale. So he takes a crew of 23 aboard this side-wheeled steamer, the Victory, and he spends 4 winters in the Arctic. So they had all sorts of misfortunes. Victory eventually gets lost. They basically abandon the ship and it sinks. And they're rescued by sort of a passing whaler in Lancaster Sound. So tell you a little bit about their exploration. So they enter through Lancaster Sound, which is up here. They pass, this is Fury Beach, where the Fury was beached and destroyed. And they overwinter several places, but they basically spend 2 winters in Felix Harbor down here. During some of that time, James Ross goes out on sledges and explores the local area. And what does he discover? He discovers the North Magnetic Pole off the coast of Boothia, the Boothia Peninsula. And so he takes measurements, and when they're there, how does he know it's the North Magnetic Pole? Well, their dip needle points straight down. They're there. So they take all sorts of readings, all sorts of measurements, right? They discover King William Land, so named after past king. They reach all the way to the west here to Victory Point. And then in sort of a somber foreshadowing, he notes that in this area, he sees kind of the thickest ice he's ever seen before. You have ice floes coming down from the north, basically piling up on each other, right? Moving far inland, destroying, building these huge, mountainous seracs. And they make it back. And they manage, at some point after their ship sinks, they have to march hundreds of miles, just like 150 miles north of Fury Beach, over land and through water, dragging their boats. And it said that John Ross was carried like a prince on one of these boats while everyone else pulled. They spent a winter at Fury Beach in very meager shelter. So, the Arctic temperature can drop to something like 40 below. It's pretty amazing these guys survived. They managed to get in their boats, row out, and sail out into Lancaster Sound and then Baffin Bay, and they were seen by a whaler. So there's one of these remarkable stories where they shouldn't have made it, but they did. And I think everyone kind of expected Arctic missions to be like that. They'd all eventually come back. Maybe some people would be lost, but not everyone. So I found it's a really neat website. It's a historical field view where it shows what the declination across the world looked like. This is for 1830, so you see the North Magnetic Pole is right there. I'm just kind of zooming in the Arctic region. You see that's the North Magnetic Pole is somewhere off the coast of Boothia, sort of around right there. But if you look, so here's what the declination looks like today. The pattern's very different. And what we find is that the North Magnetic Pole actually is moving with time. So it was located in 1830, 1904. It's drifting north slowly. So sort of today, it's sort of way up in the northern reaches. So it's changing, and that's just a result of the fact that the Earth's magnetic field is right due to these currents of molten rock and metal. And it's a very turbulent, very complicated process that's constantly changing with time, and modeling it is actually very difficult. So, all right, so Gauss enters the picture. So Gauss makes these 2 remarkable discoveries. 1832, everyone's kind of like, oh man, I should have thought of that. That's kind of those things. 1838, I think everyone's just kind of blown away. But in 1832, he discovers, hey, actually, there's a way to decouple that magnetic moment from the Earth's magnetic field. So that if you look at that oscillation and you can measure m times h, then if you take that same magnet, bring it close to a compass, and watch how far the compass needle is deflected, and you know the distance, you can work out m over h. And from the 2, you can actually decouple what the horizontal component of the Earth's magnetic field is. So you can actually measure h for real, the horizontal component, and hence you know the magnetic field. So for the first time, you cannot measure it. You can measure an absolute value for the magnetic field. And Gauss does this in Göttingen, and he gets 17,820 nanoteslas. So now you can actually measure the field. Okay. Of course, what does this mean? This means that all previous measurements are suspect and bad, right? We have to redo all our measurements, right? Because now we have better technology, better measurements. So the same, this can happen in science all the time. And then in 1838, Gauss models the magnetic field as a scalar potential above the surface of the Earth. So A here is just the Earth's radius, and then he models it basically as an expansion of spherical harmonics. So you've got sines and cosines times Legendre, associated Legendre polynomials. And he takes data from around the world, from Sabine in England and others, and he tries to map the Earth's global magnetic field. Now, the first thing I thought when I see this is like, how can you map the magnetic field? How can you represent it as a scalar function, right? Don't we use like a vector potential for the magnetic field? And you realize, okay, well, this is above the surface of the Earth, so there's no currents present. So you can, so the curl is 0, or the line element, or in a closed path should be 0, so you can model it into the scalar potential. And you can find the components of the magnetic field by taking derivatives of this scalar potential. And there's a couple different representations, but if you want declination, inclination, horizontal intensity, you can relate the two to each other. So there's a way of actually calculating and sort of fitting to a function. So this was from Gauss's 1838 paper, sort of modeling, mapping, trying to map what the magnetic field look like across the surface of the Earth. Okay. So important conclusions. The one thing you can derive the field from a potential. 2, the dipole terms are dominant. So there are some small quadrupole terms, but they're very small compared to the main dipole terms. Location of the field source is internal. There is magnetism from the Earth's crust. That's a whole separate issue. And then if you looked at a P0 term, that would represent a monopole term. And so Gauss said, hey, we should investigate and see, is this P0 term, is it actually 0? You couldn't tell from the data that they had at the time. You needed much more precise data. And so that would include sort of the P0 term was non-zero. That would mean there were magnetic monopoles, the north and south poles were different somehow and not equal. So that was something interesting and worth exploring. So science at first really is a sort of byproduct of polar exploration, and then becomes really the driving factor. So at this time period, people are going to the poles to do science, right? Science is the main driving factor. It's not exploration. So for example, when a voyage to Antarctic happens, 1839 to 1843, it's headed up by Captain James Clark Ross, so John Ross's nephew, and now Commander Francis Crozier. They sail on the Erebus and Terror. This voyage is really sponsored and instigated by the British Association for the Advancement of Science, right? Their agenda is determined by science. And if you read kind of their purpose, well, their purpose is to set up all these magnetic observatories. So they go, Van Diemen's Land is what we call modern-day Tasmania. So John Franklin was actually governor of Van Diemen's Land at the time period. They spent some time with John Franklin. All these people know each other, they're related. And basically, they go to the Antarctic to find the South Magnetic Pole and to measure the magnetic field in the Southern Ocean. And this is where that pole would have been in 1841. And notice you can't get there on land because it's on, right, the Ross Ice Shelf, which is named after Ross, right, who was captaining this voyage. So it's actually called the Great Ice Barrier, is what he called it, but now we call it the Ross Ice Shelf. But that's what the South Magnetic Pole was. But they took readings. So Van Diemen's Land, Tasmania is here. They took readings all over the Southern Ocean. Amazing stories, coming out of this expedition were, narrow misses where they sailed between, 2 icebergs, like a hair's breadth on either side of the ship. I mean, really amazing navigation, amazing exploration. And Francis Crozier and James Clark Ross come back and are sort of the heroes of the day. But Francis Crozier sort of had bad luck of falling in love with John Franklin's niece, Sophia Crawford, and she doesn't really want to be the wife of a naval captain. So he's a bit depressed on this kind of futures into sort of future affairs. So this voyage, highly successful. They get a lot of cool, great magnetic data from the southern hemisphere. And so now the question is, well, let's go back to the Arctic, right? New instruments, new methods. So who should command it? Well, James Clark Ross basically got married and had to promise his fiancée and her father that he would not go on any more Arctic missions. That was the condition of being married. So he's out. And so who's left? Well, Francis Crozier, but he's depressed. He's also Irish, and we can't possibly have that guy in charge, right? Even though he's probably the best man for the job. He's been on so many Arctic voyages. He's an Arctic veteran. Well, instead, they settle on Sir John Franklin, whose last Arctic voyage was in 1818. He's now 59 years old, and he's most famous for his overland voyages in Canada. But his wife is an amazing woman. And so the honors program is giving a 60-second lecture series on October 23rd as part of Franklin Week. And so we're talking about women in history, and I'm going to talk about Jane Franklin. And she basically bullies the Admiralty into appointing her husband as the commander of this expedition. So he gets this. And again, the vessels that are leaving are HMS Terror and HMS Erebus, or these vessels, the same vessels that went to the South Pole. And a total of 123 men sail to the Arctic. Now remember, this flies completely in the face of John Ross's idea that Arctic expedition should be small because you can't live off the land with 123 people. So John Ross actually had a lot of contact with the native Inuit. And the clash of cultures was just fascinating because at one point they caught Inuit stealing basically the captain's meal. And he said he stole his meal and he climbed into a barrel full of warm snow, which was flour, and he finished his meal and they caught him. And then the captain was so infuriated, John Ross, that he had this Inuit cane. And the Eskimo couldn't figure out why this was happening or what was going on because you're supposed to, forage for yourself. And he was being independent. And he finally realized that the conclusion he came to was that, oh, the flour must be stuck in the furs on my back and they were just helping me get the flour off. Just like you hang a rug and beat your rug out. So he couldn't understand why he was being punished for stealing, right? Because these cultures were so vastly different. They would look at the white Europeans would look at the Eskimos going, sort of that they were guilty of gluttony, right? The seal blubber that they were eating was just disgusting. Civilized people don't eat this kind of stuff. Not realizing that seal blubber is rich in vitamin C, and that's how they kept from getting scurvy. They never wondered, how are these people living out here not eating fruits and vegetables ever, but they don't have scurvy, they're surviving, they're healthy. So there's a lot of things that could have been done differently. But here's the orders, and I just want to read a couple sections. So they're provided with instruments. The latest improvements are making a series of observations on terrestrial magnetism. Right? The only magnetic observations that have been obtained by very partially in the Arctic region are now a quarter century old. It's known the phenomena are subject to secular changes. Instruments and methods of observation have been greatly improved. The earlier observations should not be named point of precision. And we want to complete this magnetic survey of the globe. So really, if you read the history and you dig into this stuff, right, the only reason this voyage was sent was to do magnetic observations. Basically, Sabine and the whole scientific establishment in Britain got the Admiralty to agree to this at tremendous expense. And so this is science driving public policy. So rather than Congress canceling the superconductor, this is science industry, right, telling us that no, we're going to build this thing. Congress be damned, right? Full speed ahead, right? We want to get our measurements. So the HMS Terror was a bomb vessel, and it was meant for mortars. Actually, this was it actually participated in the War of 1812 in the United States, where the Star Spangled Banner was written. So has an interesting history. But they strengthened the hull. They basically put lots of extra layers of wood, and then there's iron plating in the front so it could smash its way through the ice. If you see right here, you can see there's a locomotive engine installed. So hey, if you're up in the Arctic and you got to dart your way through between ice floes, if you have an engine on board, steam engine, you can do that. You don't have to wait for sails. You don't have to winch yourself through. They had internal steam heating. Basically, there was no expense spared on this voyage. This was the best equipped, most technologically advanced ships at the time. All right, here's the provisions they had on board. They carried 2,400 volumes in the library between these two vessels because they knew they were probably going to be stuck in the Arctic for the winter and, boredom. So a lot of times the sailors were actually taught to read on these voyages. They had masquerades and balls and all sorts of crazy things. They had about enough coal for about 12 days of full-time steaming, which doesn't seem a lot, but you probably wouldn't do that full-time. You'd be using coal to live in a rate and dark through these and things like that. So this was the map of the Arctic that they had that actually Franklin left with in 1845. And so here's Baffin Bay, and here's Prince Regent's Inlet. Here's Boothia. Here's King William land over here somewhere. But it shows it connected to the mainland. It wasn't shown to be an island. And that will play a very significant in sort of the fate of the expedition. So they finally leave on May 19, 1845. They have a horrible time getting to Greenland, lots of storms, things like that. Finally, they get there. They resupply. These supply ships that traveled with them, dumped off more coal, more supplies. They finally enter Baffin Bay in July of 1845. They're sighted by the whalers. And then they enter the Arctic labyrinth that no one saw, no one heard from them yet. And so there's kind of a reconstruction of sort of what happened. This is sort of historian's best guess. But the thought is that they entered Baffin Bay, entered Lancaster Sound, and their orders were to proceed west, but it seemed like this area was choked off with ice, and so they tried to head north to find if there was that open polar ocean. And so they headed north around what was called Cornwallis Land at the time. They discovered it was an island. They circumnavigated the islands. They came back, and then they spent the winter at a tiny island off the coast of Devon Island called Beachy Island. And 4 members of the crew were buried on that island. So already there was sickness. There was people kind of dropping very, very quickly. So it was very odd within the first year of an Arctic expedition for people, healthy young men, to be dying. And so the next year they continued. So here's the grave on Beachy Island. And they left no notes, no words. They were supplied with tin tubes, which they're supposed to leave on various points to, just in case a rescue was necessary. They thought that maybe they had to leave Beachy Island very quickly because the weather changed. They wanted to take advantage of that, but they didn't leave any word on Beachy Island other than the graves were there. And then after that, they head after the next summer. They head through Lancaster Sounds. They head down here between Prince of Wales Island and Somerset Island. So there's Franklin Strait, and they reach kind of this location. And then they were left with sort of a monumental choice. So Point Turnagain that Franklin had explored on land is somewhere over here. So it's only kind of this area that's not really well known on the charts. And so they were sort of left with, okay, do I go this way around King William Land, which remember they thought was a land, not an island, or do they go this way? And they're trying to go west to get to the Bering Strait. And so they go this way, and they get locked in the ice, and basically the end of the expedition. And what happens is that basically this entire sound is a giant conveyor belt for the Arctic ice. Is that you have giant pack ice clumps coming down from the north, and the weather can shift in an instant in the Arctic. So, for instance, if you have a southerly wind blowing from the south, the weather, the ice can be clear, and all of a sudden, overnight you get a northerly wind. Basically, they found themselves frozen in almost overnight, and then basically they're moving around to the pack. And so they got to about this point, and they had to abandon. They basically were locked in the ice. And they figured, okay, well, this isn't so bad. We're provisioned for 3 years. Next summer, we'll get out and we'll continue our journey. Except next summer, the ice never unfroze, or never melted. And Inuit lore tells of 2 winters with no summer in between them. So they just happened to be there at sort of a bad time. So the Franklin expedition, anything bad that could happen probably did happen. It's just, like I said, oh, what could go wrong with the best equipped expedition ever? And everything possibly goes wrong. So here's an aerial view of, this is King William Island. I think this is just in this August. And you can see that to the east, all right, you actually have some open water. But to the west, in Victoria Sound, it's just packed with ice. And so, kind of faced with that choice, and they made the wrong choice and basically got frozen in and never recovered. And they're confident about being released from the ice in the next summer. So confident they sent sledge parties out to survey King William Island. They left some notes there, but shortly after, Franklin dies. So unlike the series on AMC, he was not killed by a giant mythical polar bear in Inuit lore, but he just died of natural causes. He was 59 and not exactly in the best health. And then Crozier takes command. Now all of a sudden he's in charge of this expedition. And the summer of 1847 comes and goes, and there's no thaw. Right? They're just stuck. And so they're going on short rations. And eventually in April of 1848, they said, look, we can't possibly wait. If the thaw happened, it would come in probably not until August, and we can't wait that long. Right? So they abandoned the ships. And at this point, I think Erebus wasn't even, they're theorizing the ships won't probably even see whether they've been squashed and compacted by the ice. Ships would routinely get crushed in the Arctic ice, and they get wintered in. By this point, about 1/5 of the men of the expedition were dead. They died for various reasons, and their only hope was reaching Fort Resolution or Fort Providence, which was part of the Hudson Bay Company outpost, and those are something like 1,000 miles away to the south. So these 90, 100 men basically began this horrible journey across the ice, across King William's Island, in vain hope to reach the safety of the Hudson Bay Company outposts. And as people, they've recovered the graves on Beechey Island. They've done interesting analysis. And these men, surely many of them died from scurvy without a doubt because they're just running out of provisions. But it also turns out that there was tuberculosis on board, that all those men were dying from tuberculosis. So some of the sailors that died in the beginning were dying from tuberculosis. And it turns out that they died, that the bodies that were on Beechey Island had a significant amount of lead in their bodies. And so this was one of the first voyages that carried canned food. And the canned food, the supply was, the order was only made like 7 weeks before they left, so it was rushed. And the soldering on these cans was very sloppy with a lot of solder running into the cans. And so they think that they got a lot of lead content from the canned food. So here you go, you have nothing else to eat, there's nothing around, right? The west coast of King William Island is completely barren. There's no game, there's no nothing. The southeastern coast actually has more game, but they weren't there. And they have nothing to eat except these cans, and the cans are poisoning them. They think some of them may have died potentially from botulism as well, from the cans spoiling and going bad. There were some notes about that they left behind. So, but also just Victorian arrogance and hubris, right? The fact that after all these dark conditions, they didn't understand how the Inuit lived in these environments, nor did they really try to find out. So there's lots of rescue attempts, and I'll kind of stop with this. But Sir James Clark Ross is convinced to go out. Sir Francis Crozier was really kind of his best friend, so he convinces his wife to just let me go look for him. And he goes and he looks. He gets through Lancaster Sound, doesn't get too far. Henry Kelly goes to the Bering Strait from the other side. Maybe they made it to the Bering, on the other side. They're stuck somewhere. John Ray and Sir John Richardson travel by land, and they're looking for him. And basically, they don't come up with anything, and they keep sending Jane Franklin as this driving force of convincing people to send these rescue missions after her husband. So Collinson and McClure on the Investigator and the Enterprise, they travel to the Bering Strait looking for him. There's an American expedition by Grinnell that Jane Franklin manages to get funding for and convinces these guys to go look. Sir John Ross actually goes back again, and he gets funded by the Hudson Bay Company. And they don't discover a whole lot, and not a lot is known, but there's bits and pieces that we sort of discovered more kind of the modern day. And what's interesting is that still, as they're sending out these rescue expeditions, there's Edward Sabine going, hey, while you're going up there, I got these magnometers. I'd really like you to take along with me. And he keeps lamenting the loss of the data from Erebus and Terror. They were there for so many years, and they could have taken all this great data. And these rescue missions get hijacked. And so, for example, Lieutenant Pym gets sent to survey, we really need some data off the coast of Siberia, which is nowhere near where Franklin would have been, but they used the guys in this rescue mission to send people to do more magnetic surveying and work like that. So even in the rescue attempts, the science becomes sort of, dominant, and they sort of hijack the attempts. So what's the eventual fate of Francis Crozier? So there's Inuit tales of 40 men or so off the sort of southern coast of King William Island, dragging sledges and dragging boats. Remarkably, horribly heavy things. Remember, they have scurvy, right? The human bodies, we and I think guinea pigs are the only things that can't synthesize vitamin C. Rats will, so you can eat rats on ships. You can get vitamin C from rats, but they don't want to do that either. There's been artifacts discovered all over the place off the southern part of King William Island. And also, this was very hard for Victorian England to hear, but John Ray discovered evidence of cannibalism. And so there's lots of public outcry. Our fine British men would never resort to cannibalism. That's what savages do. Charles Dickens actually has an op-ed about this tale of cannibalism must be a lie. It's very interesting. But Erebus and Terror have actually been found. So just recently, 2016 I think is when they found Terror. And they were frozen in up at the Victoria Strait where the top dot is. They were abandoned in 1848. And then Terror was discovered around the coast of King William Island. And then the wreck of Erebus was there. And it's not clear whether the ice eventually thawed and some sailors are left behind sailed these vessels south, or they were carried by the pack ice. That was one of the great fears. If you watch the series AMC The Terror, in the very first episode, there's this great scene where Francis Crozier and John Franklin are arguing. He's saying, look, if we go this way, we'll get stuck. We'll be part of the pack. We will go where it takes us. We'll be smashed against the shores of King William Land. And they think that's probably what happened. So there's actually a postage stamp in Canada that commemorates the finding of Erebus, and that's a view of the ship lying on the bottom of the ocean. And actually, Terror was found in not that deep of water. So there was tales, stories by Inuits that saw the mast of Terror sticking up through the water, and people for years didn't believe them. And finally, they tracked this down, and they actually found the record of Terror. So, kind of the conclusions, right? There's a whole lot more to say about this Franklin expedition, right? We think that it was about searching for the Northwest Passage, about commercialism, about sort of British, national claims to fame. But really, I mean, at the end of the day, this voyage, above all else, was really about science. And so you can sort of consider the men on board the Erebus and Terror sort of martyrs of science, right? They died by doing science, right, for the scientific cause. So it's I think it's just a fascinating example of science really influencing public policy. And the whole story is there's a great lesson about something we currently debate on in science is when do you do theory and when do you take more data? And Sabine was the kind that said, well, we just keep taking data. Let's just keep taking data. And Gauss and others, I mean, Airy was the royal astronomer, was like, no, let's start doing some theory. And so there's this conflict back and forth as you read their letters and read kind of their public statements. So just one last thing to leave you with. The Northwest Passage was finally, conquered by Roald Amundsen in 1903 through 1906. And the route he took, same point as Franklin, but he went this way. But he was in the Goa, which was a fishing vessel. There was like 7 or 8 of them. Right? They adopted Inuit customs. They used, Inuit clothing, right? Rather than wearing, canvas and cottons and things like that, they wore furs. They learned how to, dog sled and things like that. So, but the passage was finally conquered. But even today, it's not an easy voyage, and there's no guarantee that any one passage that's open right now will be open next year or the year after. So. All right, thank you.